Good day, math learners. Today we'll talk about solving systems of linear inequalities in two variables by graphing. So a system of linear inequalities is a set of two or more inequalities considered simultaneously. A solution of a system of linear inequalities is an ordered pair that satisfies each linear inequality in the system. Now let's have our first example. Graph the system of inequalities x plus y is less than 5 and x plus 2y is less than -4. So for step 1, transform each inequality into an equality by changing the inequality symbol to equal sign. So let's go back first our given. Let's label our inequalities. So the first will be our inequality 1 and the second given is our inequality 2. So continuing with step 1, transform each inequality to an equality, okay, by changing the inequality symbol into the equal sign. So starting with our equation 1, inequality 1, x plus y is less than 5. So changing our inequality symbol into the equality symbol, then we have x plus y is equal to 5. Alright? Now, moving on to our second inequality, we have x plus 2y is less than -4. So changing our inequality symbol to the equality symbol, we have x plus 2y is equal to -4. Alright, so now that we are done with step 1, we can now proceed to step 2. So for step 2, we use the slope-intercept method to graph the given system of inequalities. So, okay, we will use our transformed inequality to equality. So we will use, for inequality 1, we will use x plus y is equal to 5. So let's have that. X plus y is equal to 5. Since this equation is in standard form, then let's transform this into the slope-intercept form. So isolating y on one side of our equation, we have y is equal to -x plus 5. And now we already have the slope-intercept form of our equation. Now we can already identify right away the slope, which is -1, and the y-intercept, which is 5. Now let's go to our second inequality. So we have here, again we will use, okay, the transformed equation. So we have x plus 2y equals -4. So since this equation is still in standard form, then let's transform this into the slope-intercept form. So isolating 2y on one side of our equation, we have 2y is equal to -x minus 4. Solve for y. Divide both sides by 2. So your slope-intercept form now is y is equal to -x over 2 minus 2. Because -4 divided by 2 is -2. So now we have already the slope-intercept form of our equation. We can now directly identify our slope. So for this, our slope is -1/2. and our y-intercept is -2. Okay, so we are done now with step 2. Okay, we'll proceed now to step 3. So for step 3, we need to graph the boundary line of each inequality. Okay, use dash line if the symbol of the inequality is greater than or less than, and use solid line if the symbol of the inequality is greater than or equal to or less than or equal to. Then choose test points on each side of the boundary line. Continuing, let's use now our results in step 2 to proceed with step 3. So let's have first the slope and the y-intercept of the inequality 1. So we have y-intercept is 5. Okay, locate now y is equal to 5. So 1, 2, 3, 4, 5. So here. So the y-intercept is there. Next, your slope is -1. That means from the y-intercept, we will rise 1 unit up and run 1 unit to the left. So here. Okay, so we have 2 points already. So 2 points now is enough to determine the boundary line. But before we go into drawing the boundary line, let's identify first whether we'll use dash or whether we'll use a solid line. So here, since our inequality 1 is less than, we will use dash line for the boundary line. Okay? So here, using dashed lines to determine the boundary line. We are now drawing the boundary line for the first inequality. Okay, now that we are done with the boundary line for the first inequality, we need to identify test points. Now there should be 2 test points and they should be located on other sides of the boundary line. So for this side of our boundary line, then we can use any point, no? So let's use this one. Let's have that as point A. And for this side of our boundary line, let's use this point. And let's have that as point B. Now that we have already identified test points A and B, then let's check which of the points will satisfy our first inequality to identify which side of the boundary line shall we shade. Okay, so let's proceed with test point A. So we have here. Now, the coordinates of test point A is -2 and 1. So let's have -2 and 1. So going back to our given, for the first inequality, we have x plus y is less than 5. So let's use that. So we have here x plus y is less than 5. Substitute your values for x and y. So you have here -2 plus 1 is less than 5. -2 plus 1 is -1, okay, less than 5. Now, is -1 less than 5? Yes, meaning to say, for test point A, our inequality is satisfied. So this is true. Alright, now let's still test point B. So for test point B, the coordinates of test point B is 3 and 4. So like we have 3 and 4. Now, still using inequality 1, let's try to check. So we have x plus y is less than 5. Now x here is 3 plus 4 is less than 5. 3 plus 4 is 7, is less than 5. Now is 7 less than 5? No, meaning to say for test point B, our first inequality is not satisfied. Meaning to say, we will shade the side of test point A. Okay, so shading the side of test point A. Let's use another color. Okay. Alright, so now that we are done determining which side of the boundary line shall we shade for the first inequality, now let's proceed to the second inequality. Okay, now for the second inequality, here our y-intercept is negative 2. So for the second inequality, our y-intercept is negative 2. So let's find where is negative 2. So it's here. Okay. Now the slope is negative 1/2, meaning to say we will rise 1 unit up and run 2 units to the left. So rise 1 unit up and run 2 units to the left. So here is also our second point for the second inequality. Now that we have already determined 2 points, so it's enough already to draw the line. But we still have to identify whether we'll use a dashed line or a solid line for the boundary line. So since our second inequality is still less than, then meaning to say we will still use a dashed line. Okay, so using dashed lines, let's draw now the boundary line for the second inequality. Okay, so the pink boundary line is for the second inequality. So next step will be identifying test points, okay, for the second inequality. So let's have here on this side of our boundary line, let's use this one. And let's name that point C. And for this side of our boundary line, let's use this one. And let's name this as point D. Okay, now using our test points, let's try to check which side of the boundary line for the second inequality shall we shade. So for point C, okay, the coordinates of point C are -1 and -3. So we have -1 and -3. So going back to our given, the second inequality is x plus 2y is less than -4. So we have here x plus 2y is less than negative 4. So x here is negative 1 plus 2 times negative 3 is less than negative 4. 1, negative 1. Okay, positive 2 times negative 3 is negative 6 is less than negative 4. So negative 6 minus 6 is negative 7. So we have is less than negative 4. So is negative 7 less than negative 4? Okay, true. So meaning to say, for test point A, our second inequality is true. Now let's still test point D. For test point D, the coordinates are 1 and negative 1. So let's use that. So we have 1 and negative 1. So still using our second inequality, so you have x plus 2y is less than negative 4. So we have here 1 plus 2 times negative 1 is less than negative 4. 1 minus, okay, 2 times negative 1 is negative 2. That's why it's minus 2 is less than negative 4. 1 minus 2 is negative 1 is less than negative 4. Now, is negative 1 less than negative 4? Okay, no. So meaning to say, for test point D, our second inequality is not satisfied. So again, we will shade the side of the boundary line that is in which point C belongs. So shading, we have now that we are done shading, so we can already see here that this overlapping shaded region contains the solution to the system of inequalities that we have in this example. Okay, proceeding with the last step, we need another point again in which is located on the overlapped shaded region, okay, to identify whether our shaded region is correct or not. So again, all the points that are here that are located here in this shaded region, overlapping shaded region, are all the solutions to the system of inequality that we have in this example. Okay, so let's locate now. Let's have now a point. Let's use, okay, this point, and let's have it as point E. So point E. Now the coordinates of point E are negative 4 and negative 2. So we have here negative 4 and negative 2. Okay, so going back to our inequality 1, we have x plus y is less than 5. And for our inequality 2, we have x plus 2y is less than negative 4. Okay, substitute now. For the first inequality, we have negative 4 plus negative 2 is less than 5. Negative 4 minus 2 is less than 5. Negative 4 minus 2 is negative 6, less than 5. And negative 6 is really less than 5. So meaning to say, our first inequality is satisfied. Okay? So, for the first inequality, okay, it is true. Now for the second inequality, so we have here x plus 2y is less than negative 4. So we have negative 4 plus 2 times negative 2 is less than negative 4. Negative 4, okay, 2 times negative 2 is negative 4. So that is less than negative 4. Negative 4 minus 4 is negative 8. Is less than negative 4. Now, is negative 8 less than negative 4? Yes. So meaning to say, for our second inequality, the values of x and y for our test point E satisfies the second inequality. So meaning to say, this is also true. Alright, and since test point E satisfies both of the given inequalities, then meaning to say, the region that we had here is correct. Again, I'll repeat, since point E satisfies the two given inequalities, meaning to say that all the points that are here on the overlapped shaded region are solutions to our system of inequality. Okay? So you have to really shade properly. Alright, now let's proceed to our second example. Graph the system of inequalities 5x plus 3y is less than or equal to 6 and 8x minus 3y is greater than negative 3. So for step 1, transform each inequality into an equality by changing the inequality symbol to equal sign. So this will be our first inequality and second inequality. Okay, so for the first inequality, we have 5x plus 3y is less than or equal to 6. Again, all we need to do is to change the inequality symbol into equal sign. So we have now 5x plus 3y is equal to 6. And for the second inequality, we have here 8x minus 3y is greater than negative 3. So changing greater than into equal sign, we have 8x minus 3y is equal to negative 3. Okay, so now that we are done with step 1, let's proceed to step 2. So for step 2, use slope-intercept method to graph the given system of inequalities. So we have here, we will use this one. Okay, the transformed equality for our first inequality. So we have 5x plus 3y equals 6. Isolate 3y, so you have 3y is equal to negative 5x plus 6. Divide both sides by 3. So y is equal to negative 5x over 3 plus 6 divided by 3 is 2. So now we can already identify right away our slope. Our slope for the first equation is -5/3 and our y-intercept is 2. And now let's proceed to the second inequality. So I have here 8x minus 3y equals -3. So isolate -3y is equal to -8x minus 3. Divide both sides by -3. Y is equal to, okay, positive 8x over 3 plus -3 divided by -3 is 1. So for this, our slope is 8 over 3 and our y-intercept is 1. Okay. So we are done now with step 2. Let's proceed to step 3. Graph the boundary line for each inequality. So graphing the boundary line for the first inequality, okay, which has the slope of -5/3 and y-intercept of 2. Okay, let's graph it. So let's start first with the y-intercept, which is 2. So it's here. And since the slope is -5/3, meaning to say we will rise 5 units up and run 3 units to the left. So we have 1, 2, 3, 4, 5, and then 3 units to the left. 1, 2, 3. So there. Okay, so we have 2 points already, and we only need 2 points to graph a line. So since here in our inequality 1, we are given 5x plus 3y is less than or equal to 6. And since it's less than or equal to 6, meaning to say, in graphing the boundary line, we will use a solid line. Okay? So using ruler, okay. So that is our boundary line for the first inequality. Okay, and now that we have already identified the boundary line for the first inequality, then we need to assign now test points on each side of our boundary line. So let's have here as our test point A, and let's have here as our test point B. Again, we need to have test points in order to determine which side of the boundary line shall we shade. Okay, so let's have now test point A. The coordinates of test point A is -1 and 1. So going to our first inequality, or inequality 1, 5x plus 3y is less than or equal to 6. 5x plus 3y is less than or equal to 6. Alright, so substitute now. We have 5 times x here is negative 1 plus 3 times 1 is less than or equal to 6. 5 times negative 1 is negative 5 plus 3 times 1 is 3 is less than or equal to 6. Negative 5 plus 3 is negative 2 is less than or equal to 6. Now, is negative 2 less than or equal to 6? Okay, negative 2 is less than 6. So meaning to say, test point A satisfies the inequality, the first inequality. So this is true. Now, let's still test point B. Test point B, the coordinates of test point B is 2 and 1. So we have 2 and 1. So still using 5x plus 3y is less than or equal to 6. Let's check. 5x plus 3y is less than or equal to 6. Substitute now. 5 times, x is 2, plus 3 times 1 is less than or equal to 6. 5 times 2 is 10, plus 3 times 1 is 3, is less than or equal to 6. 10 plus 3 is 13, is less than or equal to 6. Now, is 13 less than or equal to 6? Okay, 13 is greater than 6. So meaning to say, test point B does not satisfy the first inequality. So here we have false. So meaning to say, we will shade the side of test point A. Shade the side of test point A. Okay, so that is already step 4, shading the region of the test point that satisfy the respective inequality. Okay, now let's continue. Okay, let's move it here. Sige. Let's continue now. Let's graph the boundary line for the second inequality. So for the second inequality, the y-intercept is 1. So let's locate now 1. The y-intercept is 1. So 1 is here. Okay, and our slope is positive 8 over 3 or 8/3, meaning to say we will rise 8 units up and run 3 units to the right. So you have from y equals 1, we have 1, 2, 3, 4, 5, 6, 7, 8, and then run 3 units to the right. 1, 2, 3. So the second point is here. Okay, so now since for the inequality 2, our inequality symbol is greater than, so we will use dash line in graphing the boundary line. Okay? Alright. Okay, position your ruler properly. Okay. And since it's dashed line, make sure to really draw dashed lines. Okay. So now we have already identified the boundary line for the second inequality. Now let's try to check which part or which side of our boundary line shall we shade for the second inequality. And looking at our graph here, we can see that points A and points B are coincidentally located on each other side of the boundary line. So let's use them, okay, to identify which side of the boundary line shall we shade. So having test point A, test point A is at -1 and 1. And our second inequality is 8x minus 3y. 8x minus 3y is greater than -3. So substitute, we have 8 times -1 minus 3 times 1 is greater than -3. 8 times -1 is -8. -3 times 1 is -3. Is greater than -3. -8 minus 3 is -11. Is greater than -3. Now, is -11 greater than -3? No. So meaning to say, this is false. Now, let's check our test point B. So for test point B, it is located at 2 and 1. So we have here 2 and 1. So our second inequality is 8x minus 3y is greater than -3. So 8 times 2 minus 3 times 1 is greater than -3. 8 times 2 is 16. Minus 3 times 1 is -3. Is greater than -3. 16 minus 3 is 13. Greater than -3. Now, is 13 greater than -3? Yes. So meaning to say, for test point B, okay, our second inequality is satisfied by test point B. So since test point B satisfied our second inequality, then we will shade the side of test point B for the second inequality. Shade properly. Okay, so now that we are done with the shading, we can already identify the overlapping shaded region in our graph. And that overlapping shaded region consists or contains the points that satisfy the system of inequality that we have here in example B or in example 2. Continuing to step 5. Okay, let's have a test point on the overlapped shaded region. So let's have this point and let's have it as point C. So the coordinates of point C are 1 and -1. So point C, 1 and -1. So let's do now the checking. Substitute. So we have for the first inequality, 5x plus 3y is less than or equal to 6. Substitute 5 times 1 because x is 1 plus 3 times -1 is less than or equal to 6. 5 times 1 is 5. 3 times -1 is -3 is less than or equal to 6. 5 minus 3 is 2, less than 6, and 2 is less than 6. So meaning to say, point C satisfies the first inequality. Now let's go to the second inequality. 8x minus 3y is greater than -3. Substitute 8 times 1 because x is 1 minus 3 times -1 is greater than -3. 8 times 1 is 8. -3 times -1 is +3. So plus 3 is greater than -3. 8 plus 3 is 11, greater than -3. And 11 is really greater than -3, so meaning to say, point C also satisfies the second inequality. So this is true. So since point C satisfies both of our given inequalities, meaning to say, the shaded region that we have here in our graph contains the points that satisfy or contains the solution to the system of inequality 5x plus 3y is less than or equal to 6 and 8x minus 3y is greater than -3. Alright, so I hope everything is clear and see you in our next video.